Good morning, Algebra 2 students. Hope you're all doing well. Today, let's start with this problem. So it says perform the operation. Notice that we're using function notation. F of x divided by g of x when f of x equals x to the fourth plus 2x cubed minus 6x squared minus 5x plus 2, and g of x equals x minus 2. So I'll give you a second to do this problem. All right, now that we're back, let's look at what we have. So it says that we want to take the function f of x, so that would be this function, and we want to divide it by g of x, this one here. So let's write this out. So we have x to the fourth plus 2x cubed minus 6x squared minus 5x plus 2, and all that is being divided by x minus 2. So the next step would be to, what process do we want to use to divide? So you may have said synthetic division or long division. Depending on which method you prefer, you would use that method. So if we look at long division, it would look like this. So we have x to the fourth plus 2x cubed minus 6x squared minus 5x plus 2. And then if you decided synthetic division, you would know that the remainder rule tells us if we do synthetic substitution, we can see what our remainder is, and then we have all those coefficients too. So x minus 2 equals 0. First, we have to figure out what x equals. So x will equal a positive 2. So that's what we're going to do synthetic substitution with, a positive 2. And then the coefficient here is 1. So it'd be 1, 2, negative 6, negative 5, and positive 2. And if you didn't do before, pause it now and do the division with either one of those. All right, so you finished with that. So let's do the synthetic division one. So we bring down the 1 first, then we multiply 2 times 1, and then we add again. So 2 plus 2 is 4. Multiply 2 times 4 is 8. Add negative 6 plus 8. Then we multiply, add, multiply, and then 2 minus 2, we get 0. So our remainder is 0. What that means is that this function divided evenly into this one. So we're left with, since it's x to the fourth divided by x, this will be x to the third. This will be plus 4x squared plus 2x minus 1. And then this would be, and notice that the remainder is 0, so it's really plus 0 over x minus 2, which we just don't write. So then this one divides evenly. So this would be what f of x divided by g of x equals. But we also need to say one more thing, and that is something that you've learned in the past, is that if you're dividing by something, we can't divide by 0. So we have to say that this is true, but x cannot equal 2. Because if x equals 2, then we know that that would be a 0 in the denominator when we originally divided these two things. So we have to say this, and then let me just do some edit here, except, and we can just put a comma. We're going to say, but x cannot equal 2. And we're doing that because we're saying that this is in function notation. That's why we're writing this, but x can't equal 2. Just the idea that 0 cannot be in the denominator. All right, so let's move on to our productive struggle here we're going to be looking at today. Notice that the T-Rex's head and feet and the arms don't reach, so he can't push himself up. So that's just a real struggle there for that guy. We'll look at some notes, and then after the productive struggle, we'll do a couple more problems, and then do some homework correction. And today, students will be able to factor and solve. So notice that, we're going back to factoring again, and solve polynomials using previous skills. So the skills, we know how to do synthetic division, we know how to do long division, we know how to factor problems, we also know how to solve. So let's look at our productive struggle here. So how this will work is, I'm actually going to start the timer, but you'll pause your screen unless you, so then you can figure some stuff out. I'll be adding in some information in each step that I'll just be like a fake student that's giving some information that they know. So let's read through this. So 1, 0 of the equation, f of x equals x to the fourth plus 8x to the third plus 11x squared minus 32x minus 60. So notice that we have 5 terms, and then it says 1, 0 is x equals -5. Using this information, factor the polynomial completely, find all the other real zeros. So it looks like we have to do a couple things here. We have to use this information, we have to factor the polynomial completely, and we have to find all other real zeros. Notice I counted out 5 terms, so we're thinking, oh, factoring doesn't quite work yet. That's what one student might say right away. All right, so we'll start the timer. All right, so if you didn't pause during that time, pause now, and then see what you can come up with. So one student is going to say, since we have 5 terms, we can't do any factoring. And then another student said, well, if we know that a 0 is x equals -5, what can we do with that? And another student said, what about if we, what we've been doing, so like the last few days we've been dividing, so is there a way that we could divide this? Another student said, oh, factors is the same as dividing. So what if we divide this? How would we divide x to the fourth plus 8x to the third plus 11x squared minus 32x minus 60? And they want to divide it by, and they're like, x equals -5. How would we divide that? And another student was like, oh, what if like this is what we do when we're doing synthetic division? What if we just do synthetic division? So they're like on the side here, like, what if we do something like this? So they're like, all right, so let's work this out. So work that out. Pause it if you need to. All right, and we'll come back. So -5 times 1, -5, 3, -5 times 3 is a -15. 11 and -15 would be -4, +20, -12, +60, 0 for the remainder. And they're like, oh, that Mr. Myers just said that it divides evenly if you get a remainder of 0. So let's see what we have left here. And then the student's like, oh, is that right? I thought the first number was the remainder. And then they're like, no, but 0 is the remainder, and we did x to the fourth divided by x. So that means that it would be x to the third. So my student was like, what do we do now? So they reread it. They're like, using this information, factor the polynomial completely. Well, maybe we need to factor the polynomial. Can we factor 4 terms? And then another student said, well, we can factor 4 terms. We can do left side, right side. So they tried to factor it. They're like, oh, I think this is working. And then did we factor it completely? And we're noticing, oh, we actually have difference of squares. So we actually have to write that as, that's right, x plus 2, x minus 2. Now what? It says, and find all other real zeros. So we already noticed that x equals -5. So we have this. one zero of -5. What are the other zeros? Oh, we can find these other zeros here. So we can do x plus 2 equals 0. And we can see, oh, that's x equals -2. So let's put it in a -2. And then x minus 2 equals 0. So that would be x equals +2. And then, oh, we got another one here, x plus 3 equals 0. X equals -3. Oh, so we have another, let's see, so this would be -3. We can probably change that order up a bit. So we have to have a -3, -2, and a 2. So then they're like 4 zeros. Is that how many zeros we have? Another student said, oh yeah, because this is to the 4th power. So we have all of our zeros. We have factored it completely. From this part. All right, and the time just ran out. So so this is actually a way that we can solve things that we may not be able to factor. With 5 terms we couldn't factor, but since we were given this information that 1 0 was x equals -5, then we can do synthetic division with that -5. And once we do that, then we can do factoring. So it's really the steps that we did is we did synthetic division. Then what we did for our next step is we factor completely. And then the last step that we did was that's right, we solve all zeros. We'll put solve for all zeros. All right, so hopefully that was helpful. That you were able to follow through. Let's do some that are pretty similar to this. So this next one says factor f of x equals 3x cubed minus 4x squared minus 28x minus 16 completely. So we have to factor this completely given that x plus 2 is a factor. So we have 4 terms here. Can we do left side, right side right now? Can we just factor this without having to pay attention to it, without having to know this information? So we can factor out an x squared. Then we have 3x minus 4. We can divide a -4. Oh, maybe we can factor this. We're left with 7x minus 4. And we're like, wait a minute, these aren't the same. So we can't factor it yet. So it looks like we have to use this information of x plus 2 as a factor. So let's scratch that. All right, so now let's do, well, what do we have to do then? If something's a factor of something else, what do we know? That's right, we can divide these two things. So we can divide 3x cubed minus 4x squared minus 28x minus 16. We can divide that by x plus 2. It already tells us it's a factor, so we know this is going to divide evenly, meaning we know the remainder will be 0. And one thing I'll tell you now is if you're given a factor or a 0 of the function, if the remainder isn't 0, we made a mistake. So let's do our division here. Which method do you want to use? If you said synthetic division, that's something that I find that works pretty well. You can also do long division as well, which one you prefer. So if we do synthetic division, x will equal -2, because we want to solve for the 0 first. So we're going to basically substitute in this 0 of -2. We know it's already a 0, the function. And let's do synthetic division now. So we have 3, -4, -28, and -16. So what's the first step? That's right, bring the 3 down. -2 times 3. -2 times -10. negative 28 plus 20, negative 2 times negative 8, and we got a 0. So we already know that the remainder was going to be 0. That means that this is the remainder. This is the constant term, x and x squared. We also know that an x cubed divided by an x gives us an x squared. So let's rewrite this out, because notice that we have to factor completely. So that means we're going to be just factoring this one. It doesn't say solve the zeros, it just says factor. So 3x squared minus 10x minus 8. We don't say equals 0 because we're not solving it, we're just factoring it. So can we factor these three terms? And what method are we going to use? That's right, we're going to use the RS method. And the RS method, we know that R times S, so 3 times, and let me just move this over to here so we don't have to go as far. So we're going to factor using the RS method. I'll put this up top here. All right, so we know that R times S equals 3 times negative 8, which will be negative 24. And then R plus S equals negative 10. All right, so find your R and S, that works. All right, so you found that negative 12 and 2 work. So we want to do what with that? That's right, stretch the middle term. So do the factoring of this, and then we'll come back. All right, so we're back. So we have 3x squared minus 12x plus 2x minus 8. And then we can factor our left and right side. All right, and then what do we do next? X minus 4 comes out. 3x plus 2. All right, so we factored this part. And notice that it says that we want to factor this completely. So we really want to say that f of x equals these two factors and the one that it gave us. So the one that it gave us was this x plus 2. So it's really like we're writing it in factor form. All right, so factor completely, we imagine that it's going to be written as factors then, or in factor form. All right, let's look at another problem. So this next one, it says 1 0 of the function x cubed minus 2x squared minus 23x plus 60 is x equals 3. What are the other zeros? Is this like any of the ones that we just did? Okay, so if we look back, the one before, it was just factor completely, so we didn't have to find zeros there. Notice it says, what are the other zeros? So we're trying to find these other zeros. So let's look back at this other one. Oh, this one also says find other real zeros. So let's find the zeros. So this process, remember we wrote this down here, we can do synthetic division with the 0 that it gives us. We can factor completely, and we can solve for all zeros. So let's do that. Too far. All right, so let's do that. So it says x equals 3. So that means we don't need to solve it. So we can put a 3 for synthetic division, because it's already solved for x. And then our coefficients, we have 1, negative 2, negative 23, and 60. What do we know about our remainder right here? What do we know about that remainder? That's right, the remainder we know is going to be 0. So we're expecting this part to be 0 right here. That should be a 0. All right, so let's do this. So we have, let's bring down our 1. And then what do we do next? We multiply. And then what do we do? That's right, we add. And then what do? We multiply. So we get negative 20. And then 3 times negative 20, negative 60. All right, great. We got our 0 for our remainder. So remainder constant x squared. So the thing that we need to do next, if we go back to our notes here, it says synthetic division, check. and then we want to factor completely, and then we're going to solve for all the zeros. So let's factor completely. So we have to factor this x squared plus x minus 20. We want to factor that. So how many terms do we have? That's right, we have 3 terms. So 3 terms we're going to do, that's right, we're going to do the RS method. All right, so R times S equals 1 times negative 20. R plus S equals, that's right, 1. So find your R and S, do the whole process, pause it now. All right, we're back, and then let's, so R and S is going to be, you found it to be 5 and negative 4. And then you have to stretch the middle term. You already did that part 2, so plus 5x minus 4x minus 20. We're going to factor. We can take out an x plus 5, negative 4, x plus 5. So we got x minus 4 and x plus 5. Now remember, we're trying to find the 0, so after we factor that, it's really, we're trying to find the 0, so we have to set that equal to 0. All right, so x minus 4 equals 0, x plus 5 equals 0, and it's just asking for the other 0, so we just need to give these 2 things. So that means that x is going to equal positive 4 and a negative 5, so we can put in negative 5, positive 4. These are the other zeros of the function. All right, so nice work today. Let's look, and you already saw before that this is our answer key next. So our answer key from practice 2, double check your answers for practice 2. Those numbers, remember on the bottom, represent coefficients and the remainder, so then it rewrites this way. And then number 2, when you divided that one using long division. The other ones you did synthetic division, so double check the signs. You might have also, instead of putting minus, you might have said x plus 4 plus a negative 15 over x plus 4. It's fine to, these are both mean the same thing. So both of these are the same, that those both work as answers. That includes any of these ones that say minus here. All right, so that's our answer key for practice 2. And then here's your homework for today, due Friday. So we're dividing the polynomial. We're dividing f of x by g of x. Then we want to factor the polynomial, given that we have a factor for number 3. And then 4, 5, and 6. Factor the polynomial, given that x minus 5 is a factor. And then 5 says 1, 0 is 7. So notice that this is separate from the other part. So it says 1, 0 is 7. What are the other zeros? And then this one says, given this polynomial, a 0 of f is negative 4. Find the other zeros. All right, so if you have questions about the homework, either past assignments or today's assignment, remember, on Thursday, there's office hours from 2 to 4. On Friday, there's office hours from 12 to 2. So if you have questions, make sure you're coming to office hours. Even if you want to just like check in and say things are going great, that's fine as well. Whatever you need. All right, so then let's look at our ticket out. Describe the steps of factoring completely and finding the zeros of the functions, those steps that we did. And then how confident are you in doing these things? So factoring completely, solving polynomials. What is your evidence? All right, have a great day. I hope to see, well, I hope to see you on office hours, but I probably won't see you in for a while. Anyway, hope you're all doing well. And again, let me know if you have any questions or if something comes up or you need more time on something, just let me know. See you all later. Bye.